So we're going to be solving this physics problem today, and it states, a go-kart constantly accelerates from 10.7 meters per second to 15.6 meters per second in 3.7 seconds. A second go-kart leaves at the same time, but constantly accelerates from 11.2 meters per second to 16.8 meters per second in 3.5 seconds. Determine the acceleration and the distance traveled for both go-karts. Determine the difference in distance at 10 seconds. So now, with this information, we can draw a diagram to help us better understand the problem. The blue will represent the first go-kart. So we know it has an initial velocity of 10.7 meters per second. It travels at a constant rate for t equals 3.7 seconds, with a final velocity of 15.6 meters per second. For go-kart number 2, we know it has an initial velocity of 11.2 meters per second, and it travels for t equals 3.5 seconds, with a final velocity of 16.8 meters per second. With this diagram, we can better understand in that the go-karts are leaving at the same time but accelerating at different rates. The second part of our problem states that we need to find the distance traveled after 10 seconds. With all this information, we can also fill out a chart. So again, we know VI equals 10.7 meters per second. T, for time traveled, is 3.7 seconds. And VF, or final velocity, is 15.6 meters per second. We need to find the acceleration as well as displacement. For the second go-kart, we know VI equals 11.2 meters per second, and the time traveled is 3.5 seconds, with a final velocity of 16.8 meters per second. We also need to find the acceleration as well as displacement. Acceleration equals final velocity minus initial velocity, all over time. While displacement equals initial velocity times time plus 1/2 acceleration times time squared. With these equations, we can fill out all the information that we have to find both acceleration and displacement. So now let's start with solving the acceleration for go-kart 1. 15.6 meters per second minus 10.7 meters per second, which equals 4.9 meters per second. 4.9 meters per second divided by 3.7 seconds, since that is the time go-kart number 1 traveled. Our final acceleration is 1.32 meters per second squared. Now that we have gathered the information to find the acceleration for go-kart 1, we can find the displacement that it traveled in that time. So again, we know x equals vi times time plus 1/2 a t squared. We know the initial velocity is 10.7 meters per second, with a time traveled of 3.7 seconds plus 1/2 1.32 meters per second squared times 3.7 seconds. We can cancel out these units and solve. 10.7 times 3.7 is 39.59 meters plus 9.04 meters. This gives us a final displacement of 48.63 meters traveled in 3.7 seconds. With this new information, we can fill out the rest of our chart. So we know acceleration equals 1.32 meters per second squared. And we also know the displacement is 48.63 meters. We can now move on to go-kart number 2. We know go-kart number 2 had a final velocity of 16.8 meters per second, with an initial velocity of 11.2 meters per second. This equals 5.6 meters per second. And when we divide 5.6 meters per second times the 3.5 seconds that it took to travel, we get an acceleration of 1.6 meters per second squared. With this new information, we can find the displacement, which we know is x equals vi times time plus 1/2 a/t squared. We know golf cart number 2 had an initial velocity of 11.2 meters per second, with a time travel of 3.5 seconds, plus 1/2 the new acceleration we found of 1.6 meters per second squared times the 3.5 and 3.5 seconds it took to travel. We can cancel and cross out the units, which leaves us with 11.2 times 5.3, which equals 39.2 meters. And the 1.6 times 3.5 squared divided by 2 equals 9.8 meters. When we add, we get a total displacement of 49 meters for golf cart number 2. To find the displacement of golf cart number 1 at 10 seconds, we have to use the displacement equation of x equals vi times t plus 1/2 acceleration t squared. With our previous information, of the initial velocity equaling 10.7 meters per second. We can fill out that, and now we just add the time of 10 seconds to find what distance go-kart number 1 traveled at that time. So we'll do 10 seconds plus 1/2 acceleration, which is the same as 1.32 meters second squared with the new time of 10. We can cancel and cross out units, and we now know this is 10.7 meters plus 66 meters, which gives us a total of 173 meters traveled at 10 seconds. We can now move on to the second golf cart. We will be using the same equation and the information we have gathered before, but now just incorporating time as 10. So we know the initial velocity is 11.2 meters per second, and we now have a time of 10 seconds, plus 1/2 the same acceleration from before as 1.6 meters per second squared, and the new 10 seconds. We can cross out and cancel units, and we know this is equal to 112 meters plus 80 meters. We know the total distance traveled for go-kart number 2 is 192 meters at 10 seconds. With all this information that we have gathered, we can now find the difference in distance between golf cart number 1 and golf cart number 2 at 10 seconds. We take golf cart number 2's total displacement of 192 meters minus the 173 meters of golf cart number 1, and we get a difference of 19 meters.
Just as a recap for the final answer, we found